Hello, everybody. Hey, this is going to be a video on worksheet 7.4 help. Okay, now I'm going to go and do problems 1 and 4 from start to finish. But problem number 2 and problem number 3 are right here. So I'm going to stop here, and then you guys can look at this for a second. But you're probably going to need to go back and look at this at the end to kind of see and help you. All right. So problem number 1. Okay. Now, if you guys can follow along there, a 15 kilogram box. Okay. So if we have a 15 kilogram box, right? And it is going to be sitting on the ground, okay, or the floor, and it is pulled across the floor with a force of 110 newtons. So that 110 newtons would be an applied force. Okay, now the velocity is constant, and if the velocity is constant, okay, that means there is no acceleration, okay, or the acceleration is equal to 0, okay. All right, so we're going to have the force of gravity, which is also the weight, okay. And that weight is equal to mg, which would equal to 15 kilograms times 10 meters per second squared. And so our force of gravity is going to be 150 newtons. 150 newtons. All right. So we're also going to have a normal force. Now remember, a normal force is the force acting perpendicularly to the surface, and if we can see here that it is going up, and is because it's horizontal, it's going to be opposite of the force of gravity. So if we imagine this situation, we know that this box is not sinking down and it's not raising up, it's just sitting there, right? So that means the velocity in the y direction is equal to 0, which means the acceleration is equal to 0. It's not moving. So when we say the sum of the forces in the y direction, that's going to equal ma, but we know that that's 0, right? So we have the normal force, which is going to be positive, minus the force of gravity is equal to 0. We have the normal force minus the force of gravity, which we know is 150, and therefore the normal force, we're going to add 150 to both sides, is going to be 150 newtons. Okay, so our normal force is 150 newtons. Okay, now in this direction, in the x direction, in the horizontal direction, the sum of the forces is going to equal to ma, which in this case is 0 as well, because we have a constant velocity, okay? So we're going to have the applied force minus the frictional force. Now remember, the frictional force is always going to oppose the motion or potential motion, okay? So we are going to have this is going to equal to 0. We know that the applied force is 110 minus the force of friction is equal to 0. And just like this, we know that the force of friction is 110 newtons. Okay? And finally, okay, the net force in this equation. You guys, the net force up and down is 0, and the net force left and right is equal to 0. So our net force is equal to 0. All right, and then finally, we want to know what the coefficient of friction is. And the force of friction is equal to mu force normal. That's your standard equation for the force of friction. So we know that the force of friction is 110, and that's equal to mu times the normal force, which is 150. We're going to divide both sides by 150 newtons, and we're going to get mu, the newtons will cancel out. 110 divided by 150 is 0.73. And that right there is our final answer for problem number 1. All right, so obviously we have a lot to do there. All right, now we're going to do question number 4. Now question number 4 is actually trickier, so pay attention and we will go over that. All right, so I am going to start right there. I'll kind of go over this little middle part here. But number 4, Elon Musk's Cybertruck is out of energy. It has a mass of 3,152 kilograms, and it sits in the parking lot. Okay. Now, you guys, we can draw a picture. For example, here is Elon Musk's Cybertruck. Now, in the previous example, you guys, I kind of drew this box, right? But when you have things that are a little more complicated, what we can do and what we probably should do is we just talk about the forces, okay? So now right here, we can think of the truck as being right there. And now we can draw all of the forces that are acting on it. So one thing that I said in my lecture, and Mr. Calicott talked about it in his lecture, or the voiceover on the screen slideshow, okay, is everything that touches it plus gravity plus friction, okay? So now we know that the ground is touching it, and we know that that's the normal force. And we can visualize here the ground here. Remember, that's going to be perpendicular. And we also, we're going to apply a force, okay? And we're just going to apply this force, let's just say to the right. It could go to the left, right? So those are the two things that touch it, plus the force of gravity, plus friction. So we know that friction is going to oppose motion or potential motion, okay? So we know also that the coefficient of friction is going to be 0.85. So sometimes we'll see the coefficient of friction is equal to 0.85. Sometimes we'll kind of see it on that surface when you're seeing it in a document. So let's take a look at the sum of the forces in the y direction. Okay, now the sum of the forces is going to equal to ma, but as we talked about in problem number 1, okay, this truck is not going to sink into the ground or levitate. Therefore, the sum of the forces in the y is equal to 0. Okay. And we know, okay, that the normal force, positive minus the force of gravity, is going to equal to 0. So now we can take this negative force of gravity, bring it to the other side. So we know that the force normal is equal to the force of gravity, which is equal to the weight, which is equal to mg. So mass times gravity is equal to our weight. So we know that we've got 3,152 52 kilograms times 10 meters per second squared, and we're going to have 31,520 newtons. Okay, so this is equal to the force of gravity, and it's also equal to the normal force. Okay, all right, so now we are also going to talk about the sum of the forces in the x direction, and that's going to equal to ma. All right, so now we got to think about what this question is asking us, and if the static friction coefficient between the truck and the concrete is 0.85, right? So that means this one right here, this force applied, has got to be greater than, okay, the force of friction static in order to get it to move, okay? So we're just going to assume that it's just a little bit greater, all right? So now we can say, so this is really going to be 0.000000001, so just a little bit above. So what we can kind of think of it as just being greater than 0. So we're going to have the applied force minus the force of friction has got to be greater than 0. Okay, so we can kind of think of this now. The applied force has got to be greater than the force of friction. And remember that the equation for the force of friction is going to be mu force normal. Okay, so now we can say our mu is 0.85 and our normal force is 31,520, and that is going to be 26,792. 26,792 newtons, okay? So that means our applied force has to be greater than 26,792. That means it's, if it is, then it's going to start to move. It's going to start to move. Now, once you overcome static friction, the kinetic friction, okay, or sliding friction is going to be less, okay? And in this problem, it says that it drops down to 0.65. You might have experienced this if you're pushing on a box that's kind of heavy, let's say in your garage, and you go to push and it's really hard. Once it starts moving, it's a little bit easier to keep it moving, okay? And that would be an example of kinetic friction once it's moving versus when it's stationary is static friction, okay? So now we're going to assume here for this part 2, okay, that our applied force is going to equal to 26,792, okay? And now we're going to subtract our force of friction, and that is going to equal to MA, okay? And we are looking for that. We are looking for that, all right? Now, it looks like we've got too many variables here, okay? But we know a lot about this, okay? So we know that our force of friction is going to be mu force normal, which is going to be 0.65, okay, times our normal force, which is 31,520, okay, and that's going to equal to our mass, which is 3152 times A. And we still have our 26,792, okay? And that means, let me get a calculator. And so we're going to have, Calculators are not working. 1 second. All right. So here we go. 0.65 times 31,520 is going to be 2488. 2488. Okay. And that's a minus 26,792. Okay. And we're going to take 26,792 and we're going to subtract that. So that means the sum of the forces here is going to equal to 6,304. And that is going to equal to 3152 times A. And now we want to get rid of the 3152, so we divide both sides by 3152. And when we do that, we're going to get an acceleration that is equal to 2 meters per second squared. Okay, and that is problem number 4. Okay, you guys, hopefully that was helpful. You guys are, because this is more complicated, you're probably gonna have to go back and re-watch this so that if you're having trouble with your worksheet, you can kind of work it out step by step. So problems 2 and 3, you have the answers, but you still have to work it out. And hopefully this will be good. All right, take care now, till next time.